Chapter 7, Lesson 3 is going to be about transfers of energy. Let's get into it. If you remember back in the first quarter, we looked at something called the law of conservation of mass. Hopefully, you remember what it is. If you were good, you should know that the law of conservation of mass is that mass cannot be created and mass cannot be destroyed. It can only change form. Well, if you are astute enough, you should be able to make a good guess on what the law of conservation of energy will be. Also, we've been working on it with our gizmo on Sled Wars, but more on that later. The big idea in this unit is that all forms of energy can be transformed into all other forms of energy. Sometimes it's a single transformation, which means it's like a one-step problem. And other times it's multiple transformations and energy just keeps changing forms. And we'll give you a good demonstration of that. In a single transformation, the transformation is simple and it only involves one step. For example, at just this stage, the way a toaster works is that it takes electrical energy and turns it into thermal and electromagnetic energy. So it's a one-step thing. Now, we can trace this back farther as far as where's the electricity coming from. But for now, when these wires are glowing red, it is because electricity or electrical energy is being changed into thermal and electromagnetic or light. The battery in your remote control will have electrical energy, and it will turn it into invisible electromagnetic light, the infrared beam that comes out of there. And I showed some of you who paid attention in the last lesson, that there is actual light coming out of that, and there's a cool way to see it. The sun is doing nuclear fusion and turning the energy in the nuclei of atoms into light and heat, or electromagnetic and thermal. There it is. Okay, so a burner on the stove is taking a fuel which has chemical energy and turning that into light and heat, or electromagnetic and thermal energy. So when something is burning, that energy transformation is chemical to electromagnetic and thermal. And then a very simple ball rolling down a ramp, well, it's potential to kinetic. A water wheel will take the moving energy of water, or kinetic energy of flowing water, and turn that into mechanical energy on the water wheel. Other problems that you are going to have involve multiple transformations. This is where one kind of energy turns into another, and then that turns into another, and then that can turn into another. There's going to be a lot of stages along the way. So, Mr. Boggin enjoys his hot coffee every morning. Well, that thermal energy in the hot coffee has to come from somewhere. Well, if we trace it back, all the way back to the chemical energy in coal. There's more than half of the energy in Ohio comes from coal burning power plants. So odds are Mr. Boggin's getting a lot of his electrical energy from coal. So we can actually trace coal back even further, but that's a whole nother story. Okay, so we'll keep this lesson nice and short. Coal has chemical energy. We take that coal to a coal burning power plant. At the power station, there's a lot of energy transformations. All right, coal is burned. So, as to what I said earlier, whenever anything is burned, that's chemical to thermal. That thermal energy in a power plant is used to heat water, turn it into steam. So, that is thermal to kinetic. The kinetic energy of steam is going to turn something called a turbine. That's going to be kinetic to mechanical. The mechanical energy of the turbine is going to spin a generator. The generator is going to create electricity using magnets and copper wire. So that is going to be mechanical energy to electrical energy. Okay, that electrical energy is sent through wires. And then Mr. Boggin actually does have an electric kettle. And so that's going to be electrical to thermal. Then that hot water will be used to brew Mr. Bogdan's coffee. The Going all the way back to the chemical energy in coal, that actually came from plants, which got their energy from the sun. So, in if you look at it completely, nuclear energy in the sun to electromagnetic energy, light. That light gave energy to plants. Plants turned it into sugar, chemical energy. The plants died. The energy got compacted. You got coal. Okay, good. Coal was burned. So in a in a coal burning power plant, um, it is chemical to thermal to kinetic to mechanical to electrical, and then electrical to thermal to get hot water. So this is an example of several energy transformations happening. The whole point is that energy is never really created or destroyed. It's just released in changing form. Um, as what I was saying before, so the solar energy or electromagnetic energy is coming from nuclear fusion. So energy in the nuclei of atoms is being released by the sun as electromagnetic energy. That gets turned into chemical energy in plants, passed up the food chain, and so on. So almost all of the energy transformations around us can be traced back to the sun if we continue to trace it back. Well, how does a boy go kick a ball? Well, in order for the boy to have the energy to kick a ball, he has to eat something. Well, all of our food it comes from different points in the food chain, which ultimately get their energy from the sun. So the boy can kick a ball because we had sunlight. Okay, so there is this thing called the law of conservation of energy. In Energy can't be created, energy can't be destroyed. It's just changing form. So the reason why Mr. Bogdan has hot coffee, well, that's because of sunlight millions of years ago. Energy just keeps getting passed around. Now, in every energy transformation, there always seems to be some sort of missing energy or energy that just kind of disappears. Well, we know that that really can't happen. It does have to go somewhere. So, what are these energy vampires? Um, if you think about if you've got one of those bouncy rubber balls, you throw it down on the ground and it bounces super high, and then it comes down and it hits the ground. But this second time, it doesn't bounce nearly as high, and then the third time it bounces, it drops in its total height before, until eventually it just stops bouncing altogether and will eventually not leave the ground. So it seems to have lost energy. Well, in reality, instead of just being pure kinetic and potential energy transformations, it's actually losing energy to a couple of different, what I call energy vampires. First of all, traveling through the air, the ball is smacking into air molecules. That's going to transfer some of the kinetic energy of the ball to and give the air molecules more kinetic energy as it hits them and moves them out of their way. Well, the air molecules have kind of sucked away some of the energy from the ball. Also, every time you hear the ball bounce, you actually can hear it hit the ground. Well, sound is a type of energy. So that sound energy had to come from somewhere. Well, it came from the kinetic energy of the ball. And then finally, everywhere where the ball is smacking into air molecules or smacking into the ground, there's actually small transfers of heat. And so thermal energy is a major, major energy vampire. That's it. I tried to keep it short and sweet for you. You've got to read pages 248 to 253 and answer all of the questions.